the NMOS circuit shown below, VTN equals to 1 volt, Kn dash is 30 microamps per volt square, and the W by L ratios are equal. So all the parameters of both M1 as well as M2 are perfectly matched. Means 5 volts is nothing but VDS1 plus VDS2. So both are perfectly matched, means they can handle the equal amount of voltages. That is, V out is nothing but VDS2, that is 2.5 volts. Because they both are perfectly matched, VDS1 is equals to VDS2. So option C is correct. Circuit shown below, VZ is equals to 6 volts, VB equals to 0.7 volts, and beta equals to 100. Find the output voltage V0 is. Here this is 6 volts, means here also 6 volts. If across 10 is 6 volts, then across 20 is 12 volts. So complete V0 is going to be 18 ohms. That is option C is correct. Output Q is here to A ground is connected. So if any one of the input is 0 for a NAND gate, the output of the NAND gate becomes 1. So Q is 1. Whenever Q is 1, for the below NAND gate, this is going to be 0. So Q is going to remain in 1 and Q bar is going to remain in 0. That is option B is correct. Shown in figure implements. So here, suppose if I am taking this as E. E equals to C bar, B bar, and C is 0, which is C bar, B bar. F equals to, here this is 0, this is 1. Here E A bar plus E bar 0, which is E A bar, which is nothing but F is A bar, B bar, C bar, which is A plus B C whole bar according to the De Morgan's law. So this is a NOR gate, that is option C is correct.
S is equal to S plus 1 by S plus 2. We have to find initial value of f of s. Okay. Now, what is f of s here? I can divide this one as s plus 2 minus 1 by s plus 2. So this is equal to 1 by 1 plus 1 by s plus 2. Okay, 1 minus 1 by s plus 2. Now what is f of t? F of t is equal to delta of t minus e power minus t. Okay, to find initial value of f of s, that means limit t tends to 0, f of t is equal to, okay, it is having limit t tends to 0, delta of t minus e power minus t. Okay, when you go through the initial value theorem derivation, okay, initial value theorem is not valid for impulse functions. Okay, here f of t contains impulse functions. Since initial value theorem is not valid for impulse functions, the initial value cannot be determined, is the answer, option D.
Minimum phase system, the value of is, see, h of e power j omega is written as in z domain as h of z inverse. Here cos omega is nothing but z plus z inverse by 2. That is h of z inverse is equals to 5 by 4 1 by 2 z minus 1 by 2 z inverse. So which is written as to z. So if we do this one, z inverse to z and plus 1 by 4, that is 5 by 4. So if we, according to the minimum phase system, all the poles are zeros, whatever it may be, they should lie inside the unit circle. So that is possible only for this one. So h of z must be 1 by 2 z in 1 minus 1 by 2 z inverse. That is option D is
value of k for which the system is critically damped. Okay, we have to find the gain k for which the system is critically damped. Okay, he has given g of s and h of s is equal to k by, okay, I can write this one as g of s, h of s is equal to k by, what is this one? S into s plus 5 into s plus 10. So this is equal to s square plus 5s into s plus 10. Okay, now this is equal to s cube plus 15s square plus 50 into s. Now what is the characteristic equation? Characteristic equation is given as s cube plus 15s square plus 50s plus k is equal to 0. Okay, this is the characteristic equation. Now what is dk by ds? Dk by ds is equal to, we have to derive this k with respect to s. So this is d by ds times of minus s cube minus 15s square minus 50s. Okay. Now, where the value of zeta is equal to 1 be there in root locus. Okay. The only method is to find breakpoint in root locus at zeta equal to 1 is at breakpoint. Okay. That is at break-in point. If you see here the root locus plot, this is s equal to 0. Let us take, this is a point at s is equal to minus 5, and this is a point at s equal to minus 10, so on up to infinity. Now this is the branch which lies on root locus, and this will be the branch, another branch which is going to lie on root locus. Now zeta equal to 1, we have to find the value of k for which system is critically damped. That means value of k for which zeta equal to 1. Okay, it is zeta equal to 1 will be there only at breakpoints. Okay, you can remember this point at zeta equal to 1. That means we have to find at breakpoint. Now where can be the breakpoint? When two poles lies consecutively on root locus, then we can say that we have one breakpoint. Okay, how many number of asymptotes are possible here? Number of asymptotes are n minus m, that is number of poles minus number of zeros. Here we have 3 asymptotes. This pole 10, okay, this asymptote will be along this 180 degrees axis. You can also calculate plus or minus 180 by 2q plus 1 into 180 by n minus m. This will be the asymptote angles, which is equal to 60 degrees, 180 degrees and 300 degrees. That means we have a break away point here, since two poles are consecutively on the root locus. If two zeros are consecutively on the root locus, then we can say we have one break-in point. Here we have one breakaway point. That means now this breakaway point, that means these two poles will go along this breakaway point to meet asymptote at infinity, that is 0 at infinity. Now what is dk by ds? Dk by ds is given as 3 times of s square, derivative with respect to s, that characteristic equation. So this is minus 3 square minus 30s minus 50 is equal to 0. From this we can find that s is equal to minus 2.432 and minus 7.886. If you see here, minus 7.886 point, which lies between 5 and 10, this branch does not lies on root locus. That means we have to not consider this minus 7.886 point. So what is the value of s here? S is equal to minus 2.432. Now what is the value of k? K is equal to minus s into s plus 5 into s plus 10, or you can define as the value of k at s, this is at poles, divided by at zeros. Okay, since we don't have zeros, consider only denominator as 1. So what is the numerator part? Numerator part is equal to this one. So what is the k value here? K value will be approximately around 48. So option gain k is equal to 48 is the answer. Option B is correct answer.